Hello, physics student.
Hello, Meredith. Why are we currently in the Matrix?
I have brought you here to discuss recent research in the field of physics. I feel musical today. Would you like to hear about the physics of the piano?
Certainly. But how could you know about the physics of the piano? You cannot play a piano. You barely know anything about physics, either.
Actually, I can play Saria's song and Still Alive on virtualpiano.net. That's it though. And I attended Dr. Nick Giordano's lecture about the physics of the piano.
Honestly, I don't even know what pressing the key of a piano does.
Neither did I, before I went to this lecture. Through a complicated mechanism, pressing the key on a piano causes a tiny hammer to strike a wire in the piano. This wire resonates and produces the sound that we hear. The vibration is amplified by a soundboard. A pianist can control the sound volume by how hard they hit the key, something reflected in the piano's original name, pianoforte, which means soft and loud.
Has the construction of the piano changed since it was first created?
Yes. Modern pianos have a different mechanism for relaying a keystroke to a change in position in the hammer. The hammers of a piano are now covered in felt instead of wrapped in cotton. The wires are now copper wrapped around steel. These changes and others make modern pianos have larger differences between low and high notes. They are at farther ends of harmonic ranges.
I thought you said this was about physics. Get to the physics.
I hope that you remember properties of springs that we learned in class, like spring stiffness, periods, Young's modulus, and that springs can have vibrational kinetic energy. Think of a piano wire as acting like a spring. The wire vibrates against the soundboard, which increases the loudness of the sound. An important property of the wood of a soundboard is its Young's modulus divided by its density. When a wire vibrates, it produces a pitch. This is called a partial. Each wire also has a fundamental, which is the lowest frequency or harmonic a piano wire can vibrate at. Bass notes have no fundamental.
I don't care about these technical terms. Give me something practical. Why do pianos need to be tuned?
A piano vibrates in waves, and the velocity equals the wavelength times the frequency. In a perfect piano, the frequency of a harmonic should be a whole number multiple of the fundamental. This is often not the case, even though we don't hear it. The spring stiffness of the wire affects these deviations, called inharmonicities. These inharmonicities can make your piano sound super harsh and like crap. More inharmonicity means worse sound.
So what do exactly we pay the tuner people to do?
They usually adjust the tension in the wires, which is a procedure called octave stretching. This makes it sound a little bit better when the piano's double octaves aren't a factor of 2. You can visualize this by looking at a graph of the rail's backstretch, which shows the difference in pitch between the octave-stretched piano and one that was left alone. These differences are measured in cents, which is the unit of inharmonicity.
Interesting stuff.
I agree. I thought it was going to be boring because I know nothing about the technical side of music, but it was neat. I especially liked it because we had just learned about the characteristics of springs in physics class, and it is the topic I have understood the most. Dr. Giordano has done a good job synthesizing all this information and constructing a model of the physics of a soundboard himself.
This has been insightful. I did not expect a biology major to understand anything about physics.
Neither did I. I hope you decide to help me get the bonus points I need to do well in this class.